how many of these molecules are polar? So we're going to start off with the SO3, and SO3, they're both, sulfur and oxygen are both 6. They both have 6 electrons. And so that would be 6 times 4, because there's 3 oxygens and 1 sulfur, and that equals 24. And so you would draw it out, and it would it's supposed to look like this. So it'd be O, S, O, O. And you put the sulfur in the middle because it's the least electronegative, and you subtract by 6 because there are 2, 4, 6 bonds. So 24 minus 6 is 18 electrons. And so it would look like this, 6, 12, 18 dots that you put on here. And since you have to make sulfur an octet, it could either look like one of these, and the resonance hybrid would look like this. And so there are 3 domains, and that makes it a trigonal planar. And then the oxygens are going to have a negative because they're more electronegative. They're the most. And since sulfur is the least, it would be positive. And it looks like this because it's a trigonal planar. And since all the domains are the same, the bond dipoles cancel. And so it would be nonpolar. And on to the second one. So 6 plus 7 times 2. So 6 is from the oxygen, and 7 times 2 is from the fluorine, and that's 20. And before the dots, you subtract 4. So you just find 2, 4 bonds. 2, 4, bonds. And that would equal 16 dots you have to draw. So 2, 4, 6, 8, 10, 12, 14, 16. And whenever you draw the dots, you have to draw them on the outside before you can draw them. You have to fill these out first, and then you can fill the inside. And since there are 4 domains, 1, 2, 3, 4, it's a bent molecule. And so it would look like this. And the arrows, first we have to see like the electronegativity. And so these would be negative because they're more electronegative, and the oxygen would be positive. And so the arrows are going to the more negative. They're going to point towards the negative thing. And so this would be going down, this goes down. And whenever you add them together in your head, it goes down. And so it's a polar molecule. The third molecule is this. And so beryllium is 2, chlorine is 7, and times 2. So that equals 16. And you subtract 4 because 2, 4 minus 12E, 12 electrons, or that equals 12 electrons. And so you draw 12 dots, and then since you have to have an octet in the middle, you transfer one of these 2 dots into a bond on both sides. And so there are only 2 domains, because 1, 2, and that's linear. And so it would look like this. And the chlorines are negative because they're more electronegative than the beryllium. And so the arrows would be pointing opposite directions. And so they cancel. These arrows cancel, and there's no net dipole, so it's nonpolar. So this one, chlorine or carbon is 4. Chlorine is 7 times 4, and that equals 32. And you subtract by 8 because 2, 4, 6, 8. And you get 24 electrons. So 6, 12, 18, 24 dots. And since there are 4 domains, 1, 2, 3, 4, it's a tetrahedral. And it would look like this. And all the domains are the same, so it's nonpolar. And so if you look at this arrow is going down, this arrow is going up. So these 2 cancel. And this arrow is going left, this arrow is going right. And so those 2 cancel. So that's why it's nonpolar. So for the last one, you do 6 times 3 because oxygen is 6, and you just have 3 of them. So you multiply by 3, and then you get 18 minus 4 from these 2 bonds because 2 times 2 is equals 4. And that'd be 14. And since you want an octet in the middle one, it can either be this or this. and there are 3 domains, so it's bent, and so it would look like that. And then the net dipoles are both going downward, so when you add them, they become like that, and so it's polar. So the question is, how many of these molecules are polar? If we look back, SO3 we said that it was nonpolar, and then the OF2, we said it was polar. The BeCl2, we said it was nonpolar. And then we said this was nonpolar, the CCl4, and then we said that the O3 was polar. So we put a check over OF2 and then O2. And some common mistakes people make are finding like how many electrons to put on the outside, because some people forget to subtract the bonds. And another common mistake is people forget to set it up like it's like it's geometry, Ford's geometry or whatever. And so if it's bent, some people leave it like this, but it's supposed to look like this. And so if people didn't put it like this, then they would just say that this was nonpolar. But it's actually polar because whenever you add these 2 arrows, it goes down. And so it's polar.